getting back to the next part of our plan for this evening, we want to now shift focus on what our faculty, what's our status, what are we doing right now? And so, with that, and with the general spirit of iterate, and just go with it in practice, I'd like to turn this over to the first of our three faculty presenters for tonight. And each of them will be talking about different aspects. I mean, most of them do everything, but right now they're focusing on exhibiting just one of the things they do. Dr. Rob Baird needs no introduction, and so I'm going to just hand the screen over to him. Dr. Baird.
Okay, so I'm Rob Baer. I'm a physiology professor at KCOM, and I've been here a long time, since actually the early 1980s. And so in that time, I've seen a lot of new technologies. And so before I talk, strictly about AI, what I'd like to do is just take a quick look at the history of new technologies that have been here in my lifetime. So I started out with chalk and blackboard, and people were using 2x2 slides to do presentations. And then personal computers came in first as word processors. We had whiteboards, and we didn't have networks back in the early days. Then there were PowerPoint presentations. Then the students started getting computers as well as the faculty. Then the internet came, and everything changed really a lot. We had clinical cases and distant learning. Evidence-based medicine came into the fold. We had learning management systems, first Blackboard and then Canvas, smart boards, interactive classrooms with clickers. At KCUM, at least, we have an iPad initiative, so lots of students are using tablet kinds of devices. Uh, and so forth and so on through Zoom and COVID. And finally, here we are at artificial intelligence. And I've highlighted three things that I think are transformational. The personal computer really changed the way that we work. Certainly the internet, first with Wikipedia and browsers, but now as a part of this new internet, artificial intelligence thing we're seeing everywhere going on. And having gone through all these things, I guess what I want to leave as a message is it's not about the technology. It's about what we can do with the technology to improve our role as educators. And I want to sort of run us really through what I think some of these technologies have done for us. Certainly the internet made it really easy to get facts at the fingertips, at the bedside, if you will. I think what AI is going to do for us is make it easy to get concepts and whole summaries of things right when we need it, just in time, in a just in time way. But I think what we're really left with as educators and as humans is the creativity part. How do we use these AI tools to do something that is wonderful for our students? So that got me thinking about teaching as the transfer of knowledge and the ways that AI might help us. And really sort of in the fundamental ways that I can think of, it can maybe increase the depth of learning that we have our students do in some fashion, or how fast they learn something might be helped by AI, or how long they retain something that they've learned from us might be helped by AI. But the way I really started using AI and the example that came out of it that I'm going to show you tonight was the so-called Dunning-Kruger effect, where you have the student that is unskilled but unaware that they're unskilled. That is, the student doesn't know their own deficiencies, and therefore they can't productively go about repairing their own deficiencies. And certainly active learning is one of the things that we talked about when at least some of us read the book Make It Stick last year as a faculty. At least the KCOM faculty did that. And if you haven't done it in some of the other schools, I might recommend that book to you. But I got asked to do some remediation for some students that would determine whether they went on in medical school or just got left behind once and for all. And it was asked of us to do that sort of in two online sessions. And having tried flipping the classroom without much effect during COVID, I decided that maybe using quizzes might be self-study quizzes might be the way to do it. But unfortunately, if the Dunning-Kruger effect can be helped by students taking quizzes and discovering I don't know how to do this with good feedback on what they should have answered or how they should have answered it, how would I come up in a relatively short time with a bunch of clinically relevant cases? Because one of the two things I suffer from when I write test questions, one is it's really easy to know the right answer, but it's hard to find reasonable distractors for me when I'm writing test questions. And the second thing is that I'm an explanatory scientist, not a clinician, and so my knowledge of clinical context is often sort of I can't think of good clinical examples, even though I might be able to use them if I could think of them. And I thought AI might be a good way to solve this thing. So that brings us to how do I get AI to do that and prompt construction. And this template here is the one that uh, uh, Renu has asked us to sort of think about as a constant as we go through our preparations tonight. And Dr. Vita talked about this sort of in about the same way. But you have to define some role for AI as your first step. Then you nearly have to define a clear task that AI has to produce. And you have to specify the output format and the content you want output. And then you have to put it in the context of the learner. And I won't read you what I've written here, but you can look at this later if you want to get some examples of things that I did. But to tell you the honest truth, and sort of this is the quiet part out loud, I was a computer programmer in a previous life, and I do computer programming still. And I think of AI as a computer program. I've done lots of reading about large language models. And so when I designed my prompts, I sort of thought of it in a context of computers. So I want to share that as well. And what I think of AI as being is something that can access large amounts of data. Large databases are out there in the world, and then it can write software code to put it together in a nice synthetic fashion for us that is output we can consume in a short period of time in a context that we care about. So what we need to do is specify the data set that we want to use and the task that we want to solve. In my case, writing self-study questions, and the data sets that I wanted to use were my lecture material. So the problem with specifying the task is it's going to turn out edge cases. That is, things you didn't think of when you were trying to specify things in an exacting sort of way. And then one of the things I think that at least I underappreciated before I started playing with AI prompts is figuring out exactly what your output should look like. So I want self-study questions, but how am I going to give them to the students, and what should they look like, and what should the students see at one time? Because you can get the output and then spend days and days reformatting it in Word like I did with the first remediation students. I've now gone on to try and begin to do this with lectures. So the example I'm giving specifically tonight is about a lecture I just gave. But the final thing is about the learner. And that's really, I think, a part of B. It's a special part of B. But what do you want the learner to be able to get out of this? So here is my exact prompt, and I'm not, again, going to read it to you for the sake of time. But what I'm going to note is down here that as a part of my prompt, I upload my PowerPoint slides and I upload my handout for the lecture in question. Each of my handouts has a series of educational objectives on the front page, and it's got a series of open-end or Socratic questions on the last page, which I don't provide answers to because I want the students to sort of have to engage in some kind of active learning and make sure they make it their own. Do some critical thinking, if it will. And so that's what I've been uploading, but I was lucky to go hear the student presentation that Christopher Wong gave to the students last night. And one of the things he pointed out is that if we're using the Canvas L management system, that we also have access to the transcript for the recordings of our lectures. And so I included that with the things that I show in this prompt. And I ran this prompt and I put a link in the chat to the two files that got produced by exactly this prompt and those materials so you can see, evaluate with your own mind how well Gemini did, which is the engine that I used. So it's not that I just put a prompt in and got good stuff out. Uh, and so here are some of the things that in the back and forth, I had many long back and forths trying to get this process working right for myself. And so one of the things is me having to tell ChatGPT or Gemini or what's well, it's ChatGPT within the Microsoft one. Uh, and it says, give me an early warning when we are nearing the end of a prompt limit. So if you're in a prompt session, a chat session, know that you have about 30 different interactions before it ends the session. And I kept getting to the end of the session right as I'd made progress. And then I would sort of have to start over. It would, it would remember some of what we'd done, but not all of what we'd done. So be aware that there's a limit to the number of things that you can do. Uh, and I would often say, here's some additional useful information, and I'd actually give the AI some useful information to help it do what I want it to do. So don't be afraid to, be the provider of information as well as the consumer of information. And occasionally I found myself saying to AI, we are struggling and straying from our goal. What do you suggest to get back on track? Or should I start over with a new conversation? And so as we produce output iteratively, please attach a common version label to the question file and the feedback file so that we can keep track of our progress. And so again, this is an iterative process and you might want to do version tracking, or at least that became very helpful to me because then I had all these versions of the questions and I didn't know which ones were the ones where we'd solve problems, and which ones were ones that were still out in the wild. So other kinds of things, more educationally speaking, uh, I said when producing feedback, reference the handout study objectives, trying to tie it all back together. I had to tell it when it was writing questions, avoid teaching in the STEM because the NBOME doesn't like teaching in the STEM. When selecting a position for answer choices, try to end up with approximately the same number of answer choices in each slot. Interestingly, what I discovered is it uses a normal distribution to randomly assign letters to the tags. I don't know if our ExamSoft does this too, but what it means is that the most common answer was C, B and D were the second most common, and A and E were very uncommon. And so I had to tell it uniform random, not random normal, for the question things. And I spent a lot of time on that. And when referencing clinical ranges, please include normal ranges. And again, even though I said NBOME, it didn't know all the instructions that I, as an NBOME item writer, know are sort of usual things we do when we write NBOME questions. So just a couple final thoughts before I run out of time here is doing an educational task is much more than typing prompts. So define the educational task up front before you even start doing the prompts. Know exactly what it is you want to do educationally. Expect to spend some time on this process, curating your output because it won't be exactly what you want the first time. But the more time you spend on it, the less time the students who are consuming your materials will have to spend on it. And then just thinking about the students again, students have sort of a zero sum time to learn. Medical school is packed to the gills as we do this. And so if we add new AI tasks for the students, what classic tasks are we going to remove so they have time to do the new AI tasks? And sort of as individual instructors, okay, we need to balance what we're trying to do with what the other instructors are trying to do in the curriculum as a whole. So how are we going to work as a faculty within our colleges to make AI work across disciplines and not be fighting each other? It sort of potentially reminds me of when every instructor wanted to give a quiz in class so the students would pay more attention to their material. That doesn't help anybody. It just gets us into a bidding war. So AI's got to be incorporated at a curricular level as well as an individual faculty level. AI provides some opportunities for multiple learning pathways because we can create maybe more different kinds of materials for the students. But then thinking about student time again, maybe what that means is we need to think about different learning paths for different students and how we're going to guide or mentor learning choices for our weaker students or our strongest students to optimize their education in a way that AI might let us do if it didn't exist. And I guess the last technical note I have here to share with you is I played with a bunch of different AI machines. The ones that we're allowed to play with that are within our school walls. So Gemini and I'm forgetting the name of the OpenAI of the Microsoft one. Uh, but I've done DeepSeek and plain old Chat GPT, and I found that the AI engines differ somewhat. And even within an AI engine, when I come back and use it a few weeks later, it seems to change. So all of this is going to be happening and changing. And our students have AI built into Notability, which is one of the major apps that the iPad people use. And some of them are starting to use that on their own. So we've got to figure out how to integrate with those kinds of things as well. So with that, I'll turn it back to Dr. Agnihotri.